thanks for your interest in this talk. It will be on some work in which we combine text analytics, data analytics, numerical data analytics, and semantic technologies, actually. I need to find which one here. So everybody has seen at some point these impressive numbers. So they are still impressive, but they are not new. So how many data are produced in a rapid succession every minute? Yeah? So I don't read the numbers. And go from data to knowledge now. So we know this is the old version of knowledge, our libraries with books. And if you translate now knowledge to today's knowledge, you see there are large repositories of knowledge still represented in human language. For instance, the Wikipedia. Up at the left upper corner, you see the size of the Encyclopedia Britannica. And if you would print this Wikipedia in books, then you would get the books down there. Yeah? So this is growing pieces of knowledge. But this is not really it. This is not where it stops. Right now, there is an exciting movement going on that some of you may even participate in, and this is converting as much as possible of all of this knowledge, Wikipedia, textbooks, and so on, into structured data. So it started with a couple of groups and companies like Yago in Germany, Freebase, you have heard, was bought by Google, and then so spin off again. At least the data. The DBpedia, also a large European effort of many, many groups, translating as much as possible of Wikipedia and other sources into semantically usable, into structured form. And one of these projects, it may even be represented here, is Wikidata, actually based in Berlin. It's by the Wikimedia Foundation, so it's the people who published the Wikipedia, and the Wikidata project is actually here in Berlin. And Wikidata recently, as some of you have read, got Freebase back from Google. So Google said, Freebase for us was like a ladder. We climbed up on it, and now we don't need it anymore because now our knowledge graph is even bigger. Yeah? And so they gave back it to the community and said, you take care of it, together with some money to do nice things with it. So you see, I'm doing a little bit of advertisement for Google here, although I'm not the Google speaker. But Google is one of the shareholders of our research institute, and we are working very closely together with them. And some of the work, actually, I'm going to show today was supported by Google Research Awards that we got. So this is the Google, then there's pictures of the Google Knowledge Graph. You have seen it, and you all know the Google Knowledge Graph, even if you have not seen these pictures, because you know the info boxes to the right that you get when you do Google searches. And the info boxes get bigger, and now you get info boxes for types of entities for which in the past you didn't get info boxes. Yeah? So it's spreading. So now even incidents like hurricanes or train accidents have an info box. So that means all of the info, the content of these info boxes comes from the knowledge graph. So this is structured knowledge. If you click Bulgaria here, then you will get the text from the Wikipedia. On the right-hand side, it all comes from a database. And actually from a database that's has a graph-based structure. So, and this enables also natural language question answering, which actually Google does not advertise that strongly, but it's there, and every month, every couple of months, it grows, and you can ask in natural language, even in spoken language, things that you couldn't ask before. So you could ask, what's the age of Obama's wife? Or you could ask, what's the capacity of Candlestick Park Stadium in San Francisco? And it gives you an answer that comes from the knowledge graph, and then you can also, of course, go and read. So lots of things in this knowledge graphs. But this is not all of it. On the other hand, there's another very big movement that many of you know, the linked open data world. So each of the blobs here in this structure is a huge database. And they are semantically interlinked. So one of them is, for instance, the US Census. Another one is the IMDb, the International Movie Database. Another one is maybe the Genome Database. Another one is species, reference species in biology. And there could be anything. There could be train schedules. There could be anything on there. So it's all interwoven and all in a structured way. And so far, we have to be honest, the links sometimes are not very dense. So there could be much more interlinking, much more semantics in there, but it's growing from month to month, from year to year. So this is actually what we have to take into account in the future and use. And there are, of course, people who build business models on it, and others just hope that it will grow. So, but there's two exciting developments. One is the one that I just mentioned, that Web 2.0 social network, semantic web, that all grows together with Wikipedia, linked open data, DBpedia, Wikidata. And it's good that we have not just one resource, but there's a little bit of competition. But they are mainly compatible, so you can transport from the Wikidata to DBpedia and vice versa. So that's not usually it's not so difficult. So because even Wikidata has an RDF version that it can put out, and that can be read at DBpedia. So this is growing. But then there's other things like news, for instance, dynamic stuff. That does not come in structured format. But it should, because you want to combine it with the structured stuff. You want to look what has happened to the company recently, not just what's in the eternal database. And we are coming to that point, because that's actually one part of my talk. And then there's the second interesting movement that especially in Germany many people talk about, but I came back from the States, they just call it by different names. And usually people in Germany call it Industry 4.0. So in the US they said, oh, what was 3.0? I must have missed it. So, but actually then the Germans will explain. So it's there. So, and then there's the components of that is cyber-physical systems, lots of interlinked sensors and machines, automata, robots with sensors and automatic steering. They are part of the Internet of Things, but also the intelligent enterprise. So this is the higher form of business intelligence. When business intelligence comes together with planning, decision-making, forecasting, prediction, then you get really intelligent enterprises. And one of the main, and we shouldn't spend much time on that, one of the main kind of advertising pictures of Industry 4.0 people is that they say everything is smart now. Smart anything, smart chairs, smart this. So smart mobility, smart logistics, everything is smart, and there's a smart factory. But actually, when you talk to companies, which we very often do because our research center is actually owned by 20 companies, by large companies, and medium-sized also, most of the interesting stuff is not inside the factory. And people concentrate on the factory too much. They concentrated on it too much. But if you think about it, almost everything that matters, the money comes from outside, the customers come from, they're outside, the suppliers are outside, the lawmakers, the transportation, the logistics, even the people live outside. They go home after work, and they live in a different, so everything interesting is actually outside. And so the intelligent enterprise is well advised not only to analyze their own data and draw any conclusions, but combine it with outside knowledge, because that gives you much, much better results. And actually, in our project, we try to combine, to connect these two worlds. But how do we do that? So this is, by the way, a project that we are doing together. I'm the coordinator. We are doing it with Siemens and with some small, very innovative companies. For instance, the company Ubermetrics that does all that not harvests or imports all the massive data to us. And then we work with the W3C, because the German W3C center is in our office right next door. So they are actually hosted by us. The Berlin Big Data Center, and with the Wikipedia, the Wikimedia people, because of Wikidata. We have two application areas. One is supply chain management, and the other one is market research. So how do we go about it? So here's the data on the web. Oh, up there is dynamic data, all kinds of stuff every day coming in. In the middle is the Wikipedia, Wikidata, and down here is lots of other linked open data. I just mentioned those. So what's in the company? The company also they have data up there, maybe experience data. An example, yeah, they have unstructured data like repair, logs. They have partially structured things. And down there, they had usually databases or data warehouses. And we tell them now, instead, why don't you have a corporate knowledge graph? Don't try to have a Siemens data warehouse, and not every company should have their own kind of way of structuring and storing. Why don't you go with the stuff that the knowledge community does and slightly extend it to your needs? Yeah? Then you are not silos anymore. Yeah? You are connected to the rest of the world. So what we do is we build to show how that would pay off some knowledge graph in the middle that is not yet in Wikipedia. So what do you take? Is there interesting stuff that's not in Wikipedia and still of high interest? Yeah, for instance, corporate knowledge. The German Wikipedia makes sure that Wikipedia that it's not too corporate, that it's not too much favoring business in content. So if you try to put in your favorite company, your very smart startup, it will be deleted overnight. Yeah? Only the hurdles for entering Wikipedia are very high. But this is not what business wants to have access to 1.2 million German companies, small and medium and so, which we have actually in our knowledge graph. So only a tiny part of that is in the Wikipedia. So then, if you use all the same structuring mechanisms as DBpedia or Wikidata, and we use both, structure this, then we can connect to the company. But the flow is only in one direction, because do we really want Siemens and Google to put all the stuff in the... It would probably not even be a good idea, yeah, because you would get very slanted views of the world. So, but flowing in one direction is okay, but in the other direction, the public knowledge should still be safeguarded. And so up here are these dynamic data I want to talk about. So many of you do data analytics. This is a graph from, some of you will recognize it. I won't tell you what it really is. Assume those are normalized sales figures or turnovers of different units. Yeah? It's something completely different. So it could be. Yeah? And then you see, oh, all of my units are behaving about the same. So I normalize to 100%, let them start at the same point to see whether they diverge. Yeah? And then they see this black guy, very strange, very good times, very bad times. What's going on there? You correlated, that's the normal game, with other data, maybe with weather data or passenger counts. Yeah? Maybe it's a department store close to a railway station and it's influenced by the number of people who get through. So that's all the stuff that is done. You see some match, but you still cannot see really what, yeah, for instance, these peaks downwards and these peaks up, you do still. So you identify then some events, and then you search in all news and social media and try to find events. So you create events that consist out of their reflections in the numerical data and outside. Many of you have done it probably, but so we do it at a large point because we have very advanced language technology, very advanced analytics for text that we have developed over a long time. So then we find, for instance, oh, there was a Newport Yacht Fair there, yeah? And for downhill, there was maybe the closing of a railway station for a day, or something like this. Lots of stuff. So we do this actually together with Siemens for supply chain management. Siemens has about 200,000 direct suppliers, and then you can imagine how many indirect. It's very hard for them to watch them, because any delay in supply translates into big damage. If Siemens cannot finish the new power plant in Yemen or Saudi Arabia in time, then it gets very high penalties on delays. So they are really depending on the supply. So what we do then is we try to extract lots of stuff from, sorry, that was, Yeah, so I pushed once too fast. So we get things from transportation and from, let's say, RSS feeds of German railway system, of the trains, of the highway system, and so on. Things from knowledge communities, other open data like OpenStreetMap, social media. Then we get all the news. We skim 10,000s of news with the help of a company that helps us doing that, Ubermetrics. And then we take stuff from Siemens itself, and then we bring these data together for supply chain management. So how do we do the information extraction from, and that's the last little piece that we are especially proud of, because we have really perfected that part. The idea is old, yeah, it's much older. Actually, some of it goes back to a person, Sergey Brin, yeah, who published on a kind of bootstrapping of how to get a bootstrapping system for getting. But other people contributed, and we perfected it, and we have a very special way of doing it. That is a little more powerful. So we want to learn how people express the fact that the company is close to bankruptcy. Or we want to learn how we learn about a takeover or a merger or a blocked road from news, from Twitter, from anything. Yeah? How do we learn this? There are so many ways. We counted, there are 1,000 ways, we actually counted. There are 1,000 ways of expressing that two people are married. Yeah, so, or getting married. Yeah? Tie the knot, walk her down the aisle, exchange the rings, and so there are so many ways. Yeah? You cannot make them up. No person can sit down and make them up. So we take in the beginning facts, lots of facts, and we often take them from Freebase. So we take, let's say, 20,000 facts. How does Freebase about company takeovers? Yeah? 20,000 company takeovers. Company A, company B, and the year taken over. These triples we search on the web. We get lots of sentences in which they occur. When they occur in the same sentence, we parse these sentences. Syntactic parsing is not so difficult anymore. You can get your favorite parser from the New York Google group for free for your language, published in many languages. You get a dependency parse from Google. Yeah, the best parser in the world probably right now. Not probably. Provenly right now is the one by the Google New York group. And so you parse these things. And then from these parsed sentences, you extract, and now this is now the real difficult part, yeah, that we worked on for a long, long time. To really extract the right multiplace relation. Can be a relation effect that has 2 arguments, 3 arguments, 5 arguments. Yeah, can be 2 companies and a year and a place and so on. And then this pipeline for doing that, which I won't go through in detail because I don't have that much time left. So this pipeline that we have, we start with recognizing, let's say, sentences, recognizing names and part of speech. Then entity linking, we link the names with databases. We use, again, Wikipedia and external databases if our own databases don't have the names, to find out what is Bush the name or the bush, or is Buch in Germany the book, or is it the place, or is it maybe the railway station, the S-Bahn station? And is S1 in this case really an S-Bahn line? And by intersecting the S line, the geographic part of the S-Bahn with Buch, we see that the station Buch is meant. Yeah? So that's lots of stuff that needs to be done. It's huge of machinery. And in order to make it work on large number of data, we implemented it into a big data analytics platform, Flink, developed here in Berlin, by the way, like Spark, but it's more streaming-oriented. Spark is more batch-oriented. In batch, if you want to do in Spark streaming, you chop up the batch. Sorry, that's the other way around. The streaming, that's what Flink does. Actually, if you do want to do it in Spark, you collect badges, you have micro badges, tiny badges, yeah, and then you have streaming. This one is really streaming based, and it has customer memory management. So we implemented it, and this system now runs for many months. So the results right now, and actually, oh gosh, I don't have the numbers. Do I have the numbers here? Yeah, I think I have them later. It runs many months. So we built a platform, we showed it already, have a demonstrator that works for 10,000s of newspapers, and every day we get already pre-filtered the tweets by the company we work with, and so we get about 115, 120,000 tweets a day, and from these we then have to see whether the events we are looking for are really in there. And we get pre-filtered the news, and we get pre-filtered the RSS feeds by police, railway system, highway system, and so on. And those in this, they come up here, these 3 pipelines flow in. That goes all in. This is one of the pipelines for tweets. Some of these bubbles have been recognized then, and then we place it on maps. Why on maps? This is only for fun, for showing it people. I think for analytics you want to draw conclusions, but for showing it at the trade fair, the map is fine. People came at the CeBIT trade fair and they were looking at things and they said, oh, there's an accident where I live, and there's a merger, and there's a strike close to where I live, so it's fun, it's more fun for people. So, and this is about now, we have now 1.2 million companies in there in our knowledge graph, and German towns, street names, and per day this is about, oh, it's not 115, we are up to 140 now. This is the kind of stuff that we process a day, and this is the reports on events. Sometimes we cannot throw out duplicates, because sometimes a second report on a strike is really saying that it has been extended or finished. So this is all the reports on events, and this is for 3 months. Those numbers are for 3 months. This is what we gathered in the last 3 months. Thank you for your attention. Do you have any questions?